when we do the synthetic, right, we need to see if what's left, hold on, sorry, lost my train of thought there. These numbers here, right, we're about to do synthetic on, and we're going to continue using the list that we just were using. And we're going to start with what number? 2, right? We want to repeat. Now, to save us time, I'm not going to do it. Oh, it is 2. Yeah, let's do it again. Yeah, that'll be fun. So I'm going to do 2 again. I'm going to do 2 again. So I'm doing on this box here, which I could continue right here, couldn't I? But I'm going to bring it up here so you can see it. So I have -5, 16, -4, -16, and I'm trying 2 again. -5 comes down, 2 times -5 is -10. Add down, you get 6. 2 times 6 is 12. -4 plus 12 is 8. 2 times 8 is 16. -16 and 16 is 0. So we have another x minus 2 factor, don't we? A second one. And now,
so that top would be, no, the one above, should that 16x be 16x?
oh, I didn't put squared. I apologize. Sorry. Everyone catch that? I didn't put squared here. Thank you. That was the squared. Okay, what remains here comes from these 3 numbers, right? And that should be a quadratic, right? Because we started, the one we were breaking down was this one. That's cubed, so this should be quadratic. Minus 5x squared plus 6x plus 8. And so we hopefully can factor this, right? Hopefully you can factor a quadratic. But if you couldn't, you could just continue, right? You could just continue using numbers on the list. What number would you need to try next? 2 again, because it could work again. Let's just do it to see. Would it work again, you think? Let's see. No way, right? -5, -10, -4, -8, 0. It worked. A third time. So this should be x minus 2, x minus 2, and then another x minus 2, right? And then what's the last factor here? Comes from this right here. -5x minus 4 equals 0. There it is. We have completely factored that 5th degree polynomial. And we can see that some stuff is repeated, right? This right here, this right here, this right here. So that's actually cubed, which means the multiplicity is 3, right? Odd, which means it will cross there, right? Let me go ahead and get the final factored version here. We have x minus 2 cubed, and then -5x minus 4 equals 0. Set each factor equal to 0. So if I set that equal to 0, I get 0. If I set that to 0, I get 2. And then if I set that to 0, I get, what do you get if you set that equal to 0? -4/5. Right? Set that equal to 0 right there. You move the 4 over, it becomes +4. You divide both sides by -5. So it becomes that negative fraction. What now? I have the x-intercepts. What now? Not yet. Hold on. One more thing. Multiplicities, right? Bounce or cross. Bounce or cross. So let's see. This right here, what's the power on this factor? 1. 1 is odd. Odd means cross. Factor, power, odd, cross. Factor, power, odd, cross. We're crossing everywhere. No bouncing on this one. Okay? Picture time. So my graph, 0, 2, negative 4/5. Notice that when I put those there, again, I'm not really concerned with whether or not I have my spacing correct. I just want to make sure they're in the correct order, right? Because this is a sketch. We're not trying to be perfect here. Once I have my x-intercepts, I now go back and I remember what my leading coefficient has told me, which was up on the left, down on the right, right? That's what we had, up on the left, down on the right. So that means up on the left, down on the right. And I'm crossing through all of them, right? So I'm going to come down, I'm going to cross through, cross through, cross through. So cross through, cross through, cross through. That's it. That's the graph. That's the rough graph. I mean, obviously, if we graphed it on Desmos, it would look different. But I told you last time, we're not concerned in this class with how low that goes or how high that goes. Only where it crosses, where it touches, where it bounces, and where it's above and below the x-axis. All right. So I have another one I want to do here. Yeah. That's not up there. So we just did L, right? Do K for homework, okay? Why don't we do that? I already said do what? J. Just do J and K for homework. And then you can turn that into me if you want any sort of like, what's the word I'm looking for? Not extra credit, any sort of relief from what happened this morning if you didn't do well on that quiz, all right? All right, so here's one for us. How about f of x equals negative x to the 5th plus 27x cubed minus 54x squared. This problem is, there's nothing special about this problem except for one little step. So pay attention because I don't want this to catch you on a test, right? First thing, leading coefficient test, right? What's the left and right? I'll tell you when we get to that step, all right? But leading coefficient test, what's the degree? 5. Leading coefficient, -1. So the left goes up, right goes down. I'm not going to even talk about that anymore. Right? Left goes up, right goes down. Second step, find the x-intercept. Set it equal to 0. Do you see a GCF? X squared. Pull an x squared out. Do you want to pull negative x squared? We could pull negative or just leave it. What would you do naturally? Would you leave it as, would you do x squared or would you do negative x squared? How many of you want to pull the negative? How many of you want to leave the negative in? Thanks, that doesn't help. I'll just do what it's about half and half. So we'll just leave it like this. Minus x cubed plus 27x, what? X, right? I'm pulling two x's from each of these, right? And then minus 54. That good? What now? You know, a little off topic here, but on topic. When I'm sitting here and I'm showing you what to do, right, and I'm going through this with you, I know that when you're sitting there a lot of times it's like, I get it when I'm in class, but when I'm at home, I have trouble, right? It's because of this little subtle thing. I'm leading you, right? I know what I'm doing next. And then when I say it, I'm like, okay, and now I'm going to factor GCF, right? Now I'm going to, oh, this is synthetic division now, right? I know where we're going, right? I think that's where you have to like iron those things out, knowing what path you have to go down, right? Okay, so from here, it's factored. I don't know how to factor that. It's not a quadratic, right? The LC is not a quadratic. It's x cubed, not x squared. So I'm going to go to synthetic division. Synthetic. Here's a good example, right? Synthetic. What now?
The multiples for negative.
Okay, so the list, right? We're going to start with the list, right? That's the next step. List. All the factors of 54, right? And I'm looking here. Remember, I'm just in the parentheses, so I'm looking, at this. For my list, it's going to come from those, right? So 54. Okay, all the factors of 54. 1 and 54. 2. 2 goes in there, right? 2 and 27. 3. Does 3 go in there?
Yeah.
3 and 18. 4? No. 5? 6? 6 times 9. And I think that's it. 7 doesn't, 8 doesn't, 9 does. So, and are we happy about our other list?
Yes.
Yes, because it's just a 1, right? So our secondary list, where all the numbers, all the factors of 1, which are just plus or minus 1, which means ultimately this is my final list. See if you can get the next step without me saying it. Just see if you can do it. Do you know what the next step is? You've got your list. I'll give you 20 seconds. No, just I'm seeing if you can do the next step on your own. Okay. Hopefully you did this. Yes? Did you do this? Yes? Did you do this? Okay, this is the part that's different. All right. So pay attention. This was x cubed, right? Negative 1x cubed, right? Do you see an x squared here? No, right? I mean, yes and no, right? It's actually, so that we're missing an x squared term. In all the problems we've done up to this point, we were never missing a term. It was whatever the power was here, then the next power down, everything was nice and flowed real nice. Here, we're actually missing an x squared term. In this synthetic division box, you must put a 0 for the placeholder for x squared, because you have no x squareds, right? That's the part. Be careful. If you just did negative 127, negative 54, it won't work. All right? It won't work. Okay, so this is coming because we're missing the x squared term, right? We're missing the x squared term. That's why I put a 0 there. All right. Now we can do synthetic. Now, to save us time, I'm going to go ahead and tell you what works. The first number that works is negative 2. That means 1 won't work, negative 1 won't work, 2 won't work. Negative 2 is the first one that does. So it might. So negative 1 drops. Negative 2 times negative 1 is 2. 0 plus 2 is 2. Negative 2 times 2 is negative 4. 27 take away 4 is 23. And then that gives us positive, wait, hold on. Hold on. Did I look at the right thing? Hold on, I'm sorry, I think I looked at the wrong thing. I'm sorry, I apologize. Okay, well that shows you that -2 doesn't work. Okay, what did this come out to be? 46? Okay, it doesn't work.
The negative life won't work.
Okay, so 1 doesn't work, -1 doesn't work, 2 doesn't work, -2 doesn't work, 3 does. Sorry, I was just looking at the wrong thing. So let me do 3. I'll just put it up here. Try 3. So -1, 0, 27, -54. I said 3 works. So -1 comes down, -3, -3 when we add down, -9, 18, 54, 0. Okay, so that works. And now that tells me that this over here factors to be x squared. Then? X minus 3. And then I will have a quadratic here, right? Because when I was doing this, we were breaking this down. This was a 3rd degree polynomial. And so that when I do synthetic, it's going to give me a quadratic. It'll be -x squared minus 3x plus 18. You can go factor again. You could either try and factor this using like what you already know about things, or you could do synthetic a second time. Totally up to you. Let's do synthetic again. I believe 3 works again. It doesn't? No, 3 should work again. Let's do 3 again, all right? I'm gonna do it right here on this. 3 here. -1, -3, what's this? Negative, we're adding. -6, careful. -18, 0. See? So that works, which tells me that I have another x minus 3. And in the other parentheses, I have what? -x take away 6 equals 0.
So that just defaults to x plus 6.
Well, it depends. If you were solving the equation, then yes, you could just say this is the same as x plus 6. But you can't ignore the negative when it comes to the shape of the graph. That does have an effect. We all right here? Okay, so what I'm going to do now, I'm going to get a final result here, set equal to 0. I do see I've got some multiplicity action going on, right? I've got x squared, I've got x minus 3 squared, and then I have -x minus 6 equals 0. What now? That's what will happen, correct. But what have I been doing next before that step? Set each one equal to 0. Okay? So set this equal to 0. What do you get? 0. Set this to 0. 3. Set this to 0. Okay. Set that to 0. Right? Move the 6 over. Divide by -1. -6. Right? -6. Now, bounce, bounce, cross. Bounce, bounce, cross. Ooh. Picture time. 0, 3, -6. It went up on the left, down on the right. it crossed, it bounced, right? Cross, bounce, bounce. There it is.
So it can't cross twice with a bounce, or
It can't cross twice with a bounce. But I'm not sure.
so for the odd ones, they can have a weird number of crosses to the bounces, because then it'll
Yeah.
line up twice.
So if you had a degree 5, it would be impossible to bounce 3 times. Right? Is that what you're saying? I don't know if that's what you're saying.
I think so.
Like if you're degree 5, right, you couldn't bounce 3 times, because then each of those bounces would require an even power. So that'd be 3 bounces would be 3 times 2, 6. That'd be degree 6. How do you feel? Feel all right? You all understand? Know what you're supposed to execute? What's your question?
Okay, so whenever we're doing synthetic division,
Uh-huh.
are we adding the number on the side of the division box, or are we looking at another number when we do it?
Are we adding it, or are we what?
Are we adding it? Are we adding it to whatever we got from the bottom?
Yes. The word's not adding. We're combining it together.
Oh, okay.
Yeah, I mean, we're not adding it. We're just saying it's that factor. The numbers on the bottom tell us something, and the number up there tells us something. All right. So this factoring technique is pretty awesome, right?
Yeah.
I mean, it's pretty impressive what it can do, but there are limitations, all right? I don't want you to think it's like the magic pill, right? So I'm going to give you an example. Let's solve this equation. Nope, I didn't mean to do that. All right, so I'm stepping away for a moment here to just talk about solving equations in factoring. If you look at this right now, can you solve that equation? Well, you could just move the 2 over, couldn't you? Add 2 to both sides?
Then square root.
And then square root both sides. And when you square root, you'll have to do plus or minus, won't you? And so you get plus or minus root 2. Yes? Those are the 2 solutions to that. Let's act like we didn't know how to do this. And let's look at this side and try synthetic division. Let's try it. Let's try and factor that. So what's my list? 1 and 2. And then my other list comes from the number in front, which is 1. So I only have 4 numbers, right? This is my final list. Careful. What's the synthetic division box? What's in here? 1, 0, negative 2. Why is there a 0? Because it's missing an x term, right? It's missing an x term. 1, 0, negative 2. Got it? Let's try our numbers. See if 1 works. I'm going to go very fast. Does 1 work? 1. No, 1 doesn't work. Okay, does negative 1 work? 1. Negative 1. Negative 1. 1. Negative 1. Doesn't work. Right, sorry, that was negative 1. Doesn't work, right? 2 more to try. Try 2. 1, 2, 2, 4. 2. Doesn't work, right? Last one. I know I'm going fast. Negative 2. Doesn't work. What the hell? Right? The synthetic division will only ever factor something if your factors are rational numbers. What is a rational number? A whole number or a fraction, okay? A whole number or a fraction. If your factors or your zeros are square roots, like irrational numbers, this method doesn't work, all right? So it is actually beautiful, but at the same time, it's very limited. Now, I'm not going to throw anything like that at you. It wouldn't be complete for me to not mention that. It doesn't always work, all right? Yes?
When could it come into play?
probably everywhere else in the real world, like in the real world, a lot of times our answers are not nice numbers. So instead of trying to do this, we use a computer algorithm to do it. So the computers will definitely fill in all of the holes that we have. In calculus, we learned something called Newton's method, and it's a way that we can find solutions to any equation. It doesn't even have to be a polynomial. All right, so for homework, you are going to do J and K, right? J and K. And then let's do two more. All right, let's do two more, and then we're going to call it a day. All right? So the other two that I want you to do are, make sure it's not that one, yeah. I want you to do x to the 6th minus 2x to the 5th minus 11x to the 4th plus 12x cubed plus 36x squared. And then these are not in any particular order, like, oh, this one's harder than the other one, or this last one, let's go x to the 5th plus 6x to the 4th minus 3x cubed minus 20x minus 12x. And I'm just going to double check these because if I messed anything up here, it will be a disaster for you. Okay. X to the 6th minus 2x to the 5th minus 11x to the 4th plus 12x cubed plus 36x squared. Okay, that's it. Okay? So the instructions are to do what we did in class, right? Sketch these. You should have leading coefficient test followed by setting it equal to 0 using your synthetic division. Don't just give me answers. I'd like to see you like actually have the work there, all right? And then a nice picture at the end. Yeah, let's turn these in. Because when I think of what your next test is going to be, you're going to have to do one of these, maybe two. So this is really like an opportunity for you to practice what you're going to see on a test, all right? So those two, along with those two, to turn in next time, all right? Okay, yeah, I don't know. We'll say this. Do all four for homework, all right? Those two turn in to me if you want any sort of help on what happened to you here, all right? J and K, you turn in, but you should do all four for homework, all right?
So we're not doing these in.
You don't need to turn those in. Well, you don't need to turn anything in if you think you did well. Like if you got that answer right, you don't need to turn anything to me on Tuesday.
If you want to.
But if you can, if if you want to, you can.
Just make sure.
Yeah. All right. So look, we're going to cut out a little early here, but a little more tough love for everyone here. So, please meet the expectations of the class, all right? Meet the expectations. So if I'm sending you home to do something and I've given you instruction, meet that challenge, do your part, all right? And then come in for help too if you need it, really.
Is that what the 20
Is that, oh shit, I thought, there's a typo.
Yo.
I even double checked it. Hold on.
Is it plus?
Oh my gosh.
It's the x squared.
It should be x squared on the 20. All right, you get +5 for calling that for me. All right, just when you turn it in, write it on the top. You owe me 5 points for your mistake. Okay? Only one person gets to do that though. Okay.
I thought of it.
You thought of it? Okay. All right, there you go. You'll have a good weekend, all right? We start rational functions next week.
Oh, no.
Yeah, thank you, excuse me. They're a combination of what we just did.